Hello everyone, my name is Shashank and I am from Sri Venkateswara College of Engineering. Today we are going to learn about Pixar. What are all the contents we are going to learn in this PPT? First, introduction, algorithm and example, complexity, applications and conclusion. Now let us start by the introducing sorting. A sorting or a sorting algorithm is a method for reorganizing a large number of items into a specific order such as alphabetical highest to lowest value or to shortest to longest distance. Quicksort is a popular sorting algorithm that is often faster in practice compared to the other sorting algorithms. It utilizes a divide and conquer strategy to quickly sort data items by dividing a large array into two smaller arrays. It was developed by Charles Anthony Richard Hoare, or Tony Hoare or CAR Hoare, born in January 11, 1934, is a British computer scientist and winner of the 1980 Turing Award. He is the best known for his fundamental contributions to the definitions and design of programming languages and for the development of Quicksort, the world's most widely used sorting algorithm. Now let us learn about algorithm for Quicksort. Algorithm Quicksort of A of L to R sorts a subarray by Quicksort. Input a subarray A of L to R of A of 0 to n minus 1 defined by its left and right integers L and R. Output subarray A of L to R sorted in non-decreasing order. If L is less than R, S to partition A of L to R by S is a split position. Quicksort of A of L to S minus 1. Quicksort A of S plus 1. Algorithm partition A of L to R. Partition a subarray by using its first element as pivot. Input a subarray A of L to R of A of 0 to n minus 1 defined by its left and right indices L and R. L is less than R. Output a partition of A of L to R with the split position returned as this function's value. P to A of L, I to L and J to R plus 1. Repeat. I to J plus 1 until A of I is greater than or equal to P. Repeat I to J minus 1 until A of I is less than or equal to P. Swap A of I, comma A of J until L is greater than or equal to J. Swap A of I, comma A of J. Undo last swap when I is greater than J. Swap A of L, comma A of J. Return J. Now I am going to explain about how the quicksort will be working with an example. The problem is the example itself. Now we are going to take pivot element as E and the leftmost array will be E and the rightmost array will be L. So first we are going to compare pivot element with the left if it is less than or greater than the pivot element. Now because E and E are equal which is not less than the pivot element, we are going to stop at the current position. Next we are going to compare the L which is greater than or less than the pivot element. Because L is the greater than the pivot element, it will not, it will, the right will be moves towards the left element. Like this, the comparison will move up to until the right element and left element stops at the current position only. A is at stops at the current right will be stop at A, which will be stops at the current position where pivot element E is less than the right is less than the pivot element. So then the left and right will be get compared. If the right element, if the left element is less than the right element, then it will get swapped. If not, it will be same. After the swapping, it will get something like this: A, X, E, M, P, L, E. Next up, left element will be increased by 1 and the right element will stop at the current position. Next, we are going to compare left and right once again. Because pivot element is greater than left element is greater than the pivot element. So, and the left element is greater than the right element, it will get swapped. And A, E, X, M, P, L, E after swapping. Next, we are going to take, then left and right will be at same position because right is X element and the right is greater than the pivot element, so it will move towards the right side, left side. When the both element is in equal, like left and right element is on the same position, the new pivot will be formed, or the new value of pivot element is formed. Next, the left subarray will be A and E, and we are going to compare, and it will be divided by XMPLE. XMPLE will be the new array. Next, the new pivot element will be E once again, and it will start comparing with other elements. It will go as follows. Once again, the pivot element is not like left is not less than the pivot element and right is also greater than the pivot element. When both are at the same, the left and right element which are in the current position will get swapped with the pivot element. Like X is the left and right element, both will be at the same position. So the pivot element will get swapped by the X element E. Next, after the swapping, E will go to the left subarray. E will go to the left subarray, and X will become the new pivot element. Next, it will pivot X will be compared with the left and right. When X is compared with the left uh, element M, it is less than the X. So the left element will get increased and the right element is in the current position because it is less than the X is L is less than the X. And left element and right element will once again compared with the pivot element. X, P is less than the X and L is also less than the X. So left element will move towards the right direction, and right element will be at the current position. Now the left and right element are at the same position, so X will be a uh, X will become the new right subarray and L will become the new pivot element. Next, L will get compared with left and right. P and the pivot element with compares with the right element, and is the greater lesser than the L, so P will move towards the right, and M is the greater than the L, so M will left will be stops at that current position. Now M and L will be swapped, and L will move towards the left subarray, and P and M it will both will compare, and M and P will be swapped because M is lesser than the P, so it will get swapped. Next, the final result combining all the sorted arrays are A, E, E, L, M, P, X. After the example, we are going to complexity. There are two types of complexity: space complexity and time complexity. The time analysis are have input parameters n size of array A, basic operations comparisons. There is a variation of time for the same size n. So we have to find best case, worst case, and average case. The time complexity. The average time complexity for quicksort is O of n log of n, which makes it faster than many other conventional algorithms like bubble sort or insertion sort. However, it's important to note that the worst case scenario can cause an O to the power of n square complexity, which can cause performance issues for extremely large data sets or systems with limited memory usage. The best case has O of log of n. Average calls are also same as the best case O of log of n, and worst case is big O of n square. Now the space complexity. Quicksort has an O of log n space complexity, making it an excellent choice for situations when space is restricted. Applications of quicksort. The sorting algorithm is used to find information, and as quicksort is the fastest algorithm, it is frequently employed as a more effective method of searching. Quicksort has an excellent locality of reference when applied to arrays, making it a cache-friendly algorithm. It is an in-place sort, therefore no additional RAM for storage is needed. The kth, smallest or largest components are separated using quicksort variants. For the aim of the sorting different types of data such as files by name, date, price, or students by roll number, account profiles by provided ID, etc. Commercial computing is employed in a variety of public and private businesses. Conclusion. Sorting algorithms play a crucial role in computer science and everyday life, which helps in organizing the things. Quicksort is more efficient and faster than the other sorting algorithms. Its time complexity plays the major role in the sorting. Now we are concluding everything. I hope everyone understand how the quicksort going to work and example of the quicksort.